Imagine a star so extreme that its magnetic field could tear apart atoms millions of kilometers away. This audiobook invites you on a journey deep into magnetars, the densest and most mysterious objects in the universe after black holes. Dead stars that, instead of fading away, transform into invisible giants capable of altering the matter and space around them. What makes them so powerful, and what secrets do they hold about the limits of physics? A serene exploration of one of the most perplexing phenomena in the cosmos, perfect for letting yourself be carried away while you rest. Magnetars are a special class of neutron stars, but not just any neutron star. They are created in the cataclysm of a supernova when a massive star explodes at the end of its life. However, not all neutron stars are magnetars. The difference lies in their extraordinary magnetic field, which can be 1 trillion times stronger than that of Earth. To give you an idea, if a terrestrial compass points north, a magnetar could divert the course of a spaceship light years away. Isn't that amazing? The importance of magnetars in the context of modern astrophysics cannot be overstated. They help us understand not only the life and death of stars, but also the limits of physics as we know it. Exploring these cosmic objects leads us to question fundamental concepts about matter, energy, and gravity. What could a magnetar reveal to us about the nature of the universe? When we think of space, we often imagine it as a silent and empty place, but that is far from the truth. In reality, it is filled with forces and phenomena that, although invisible, are in constant interaction. Magnetars, with their immense gravity and magnetic fields, are like giants dominating their surroundings, affecting other stars and potentially even planets. As we explore the phenomenon of magnetars, it is inevitable to wonder, how do they form? The answer is as dramatic as the fate of the stars that create them. A supernova, an explosion so bright that it can outshine an entire galaxy, is the stage where these magnetic giants begin to take shape. But not all supernovae produce magnetars. Only those that meet certain specific conditions give rise to these peculiar cosmic phenomena. Moreover, the study of magnetars invites us to reflect on their uniqueness. While most neutron stars have strong magnetic fields, magnetars take this to an extreme level. What does this mean for the space surrounding them? The answer is simple. Their influence is vast and powerful, generating X-ray and gamma emissions that are literally explosive. These emissions are not only fascinating, but also offer a window into the physical processes occurring at the edges of the universe. As we delve into the world of magnetars, it is natural to wonder, what about their lifespan? The life of a magnetar is not eternal. Like stars, they have a life cycle. And in the case of magnetars, this cycle is brief but intense. Their existence is marked by spectacular phenomena, leading us to ask, how much longer will we be observing these cosmic titans? Once we begin to understand the existence of magnetars, curiosity also arises about their distribution in our galaxy. Where are they located? Are they rare or common? As astronomers work to identify them, they have realized that although they are not abundant, they play a crucial role in the structure of the Milky Way. The detection of magnetars is another intriguing topic. How do we know they are there thousands of light years away? Thanks to advanced technologies and innovative observation methods, researchers have managed to capture their signals. These signals are like whispers from the cosmos, telling us stories about their nature and behavior. Magnetars also spark great interest due to their impact on contemporary astrophysics. They force us to rethink many theories and principles that we believe to be solid. Their study not only allows us to see the universe in a new way, but also challenges us to think about what we really know about matter and energy. In the end, magnetars are not just a scientific curiosity. They are a reminder of how vast and mysterious the universe is. Each one carries secrets that could change our understanding of the cosmos. What else are they trying to tell us? Exploring the world of magnetars is like opening a door to a new realm of knowledge. It invites us to keep asking, investigating, and marveling at the grandeur of the universe. The adventure is just beginning, and what we discover about these cosmic titans could be just the tip of the iceberg. So fasten your seatbelt and get ready for a journey through the wonders of space. Magnetars are one of the most intriguing phenomena in the universe, but what exactly are they? In simple terms, a magnetar is a special type of neutron star, which are extremely dense remnants of massive stars that have exploded in a supernova. However, what truly distinguishes a magnetar from other neutron stars is its astonishing magnetic field. Imagine that the magnetism of a refrigerator magnet is powerful, but a magnetar has a magnetic field that can be 1,000,000,000 times stronger. It's as if instead of a simple kitchen magnet, you had a supermagnet capable of affecting everything around it at incredible distances. When a star forms, its core collapses at the end of its life, and in the case of massive stars, this collapse leads to what we know as neutron stars. But not all neutron stars become magnetars, only those that have specific characteristics and meet certain conditions during their life and death. So what factors determine whether a neutron star becomes a magnetar? The answer lies in its rotation and how it cools after the explosion. As they spin, they generate a magnetic field that intensifies. And if that field reaches a critical threshold, it becomes a magnetar. The characteristics of magnetars are fascinating. Not only do they have an immense magnetic field, but they also exhibit extremely rapid rotation, often spinning several times per second. This makes them some of the most enigmatic objects in the universe. But why is it so important to study magnetars? The reason is simple. They help us better understand the physics of matter under extreme conditions. In magnetars, gravitational and magnetic forces are so intense that they challenge our current understanding of physics. Moreover, magnetars are known for their highly energetic activity. Emissions of X-rays and gamma rays are common in these objects, which are a consequence of their intense magnetic activity. But why do they emit so much radiation? This radiation is due to the fact that a magnetar's magnetic field can release energy in the form of explosions, causing them to become sources of X-rays and gamma rays, some of the brightest observed in the universe. This means that they are not only interesting because of their nature, but they are also important for astronomy, as their study can provide clues about the evolution of stars and the behavior of matter under extreme conditions. The classification of magnetars is based on their properties. There are rotation and field magnetars. Rotation magnetars are those that spin rapidly and possess an extraordinarily strong magnetic field, while field magnetars are less active rotationally but have a magnetic field that can be even stronger. This diversity in their characteristics makes each magnetar unique, almost as if each one has its own cosmic personality. When we talk about magnetars, it is natural to wonder how scientists detect them. The answer is fascinating, as telescopes are used to capture the high-energy radiations they emit, such as X-rays. These emissions are so powerful that they can be detected from thousands of light-years away, allowing us to study these objects despite their distance. However, detecting magnetars is not always straightforward, as their activity can be intermittent. Sometimes they are extremely bright, and other times they seem to disappear, which keeps astronomers on their toes. Magnetars also allow us to explore the limits of our knowledge about physics. When investigating how these objects interact with their environment, phenomena that have not been seen before are discovered. For example, their radiation can influence the interstellar medium surrounding them, generating shock waves and affecting other celestial bodies. This is a reminder of how interconnected the universe is, where such a distant object can have effects on its surroundings. The life of a magnetar is not eternal. Although they can exist for thousands of years, their intense magnetic activity causes them to burn out quickly. Eventually, a magnetar is expected to face its own extinction, resulting in the release of a large amount of energy. This process is still a mystery that scientists are trying to unravel, and each discovery about their lifespan brings us one step closer to understanding the evolution of the universe. In summary, magnetars are a reminder of how extraordinary the universe is. These objects not only challenge our notions of physics, but also offer us a window into the extreme conditions that exist beyond our planet. Each magnetar is like a beacon in the darkness of the cosmos, guiding us toward a greater understanding of matter and energy in its purest form. As we continue to explore and learn about these fascinating objects, we discover that the universe has much more to offer than we could have ever imagined. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey. Magnetars are one of the most intriguing phenomena in the universe, and their formation is quite an astonishing process. To understand how a magnetar forms, we first need to explore the powerful and impressive life cycle of stars. When a massive star has exhausted its nuclear fuel, it faces an inevitable and dramatic conclusion. Did you know that this final phase can result in an explosion so bright that it can outshine an entire galaxy? This explosion is known as a supernova, and it is the first step in the formation of a magnetar. A supernova is like the grandest fireworks display you can imagine. In a matter of seconds, the star violently breaks apart, ejecting its outer layers into space. But what happens to the core of the star? This core, which has survived the explosion, collapses under its own gravity. At this moment, the pressure and temperature inside reach extreme levels, triggering a series of astonishing events. In this context, the core can become a neutron star, an extremely dense object where a single teaspoon of material could weigh as much as an elephant. Now, this is where the magic of magnetars comes into play. Not all neutron star cores become magnetars. For this to happen, certain special conditions must be met, and the key lies in the magnetic field. Imagine that each neutron star is like a highly magnetized metal sphere. In the case of magnetars, this magnet is incredibly powerful. While the magnetic field of a normal neutron star is already impressive, that of a magnetar can be 1,000 billion times stronger. This extreme magnetic field is what makes magnetars unique, and it is the result of a process called dynamo action. During the formation of the magnetar, the movements of hot plasma in the core, combined with gravitational collapse, generate a magnetic field that intensifies. But what does this mean in terms of a magnetar's life? It means that, like a very powerful magnet, a magnetar has an effect that goes beyond its own existence. Its magnetic field can influence everything around it, even affecting the behavior of other nearby stars and celestial objects. So how long does this formation process take? The creation of a magnetar is rapid in astronomical terms, but the result is an object that can live for millions of years. However, throughout its life, the magnetar will continue to experience changes. As it emits energy in the form of radiation, its magnetic field may lose intensity, but not before leaving an indelible mark on the surrounding space. The conditions that lead to the formation of a magnetar are so specific that it is believed that only 1 in every 10,000 neutron star cores becomes a magnetar. Imagine how rare this is in the vast universe. Every time one forms, it becomes an exciting object of study for astrophysicists who are trying to unravel the mysteries they hold. The search for magnetars has also led scientists to develop new technologies and observation methods. The tools we use to study these objects not only help us better understand the nature of magnetars, but also expand our understanding of the universe as a whole. Every discovery about a magnetar is like opening a door to new questions about how physics works under extreme conditions. So why should we care about the formation of a magnetar? Because these objects are not only fascinating in themselves, but they can also provide clues about cosmic events that have shaped the universe as we know it. Magnetars help us understand the evolution of stars and the dynamics of galaxies. Every time we study a magnetar, we are taking a glimpse into cosmic history. The formation of a magnetar is a reminder of how small we are compared to the vast universe. But it is also a testament to the incredible diversity of phenomena that occur in the cosmos. Each magnetar is a beacon of knowledge, an object that invites us to explore and learn more about the forces that shape our world and beyond. So when you look up at the night sky, think about the astonishing processes that have led to the stars we see. Some of those flashes of light may actually be the remnants of supernova explosions that have given rise to magnetars. In a sense, Those distant lights are a reminder of the beauty and complexity of the universe we inhabit, a universe that continues to surprise us at every turn. Magnetars are true wonders of the universe, but what really amazes is their magnetic field. Have you ever wondered how powerful a magnetic field can be? Imagine for a moment that you have a magnet in your house. A common magnet can attract metallic objects like paper clips or screws, and if you bring it close to your phone, it will probably affect it in some way. Now, what would happen if I told you that the magnetic field of a magnetar is so strong that it could pull an object the size of an entire city towards its surface? In the case of magnetars, their magnetic field is billions of times stronger than any magnet we can find on Earth. To put this in perspective, the magnetic field of our own planet is about 1 microtesla. But a magnetar can have a magnetic field that reaches up to 1,000 trillion teslas. This is such an enormous amount that it is almost unimaginable. Can you imagine a magnetic field capable of destabilizing matter itself? This extreme magnetic field is not only impressive for its magnitude, but also for its effects. When a magnetar spins, its magnetic field can generate intense radiation, but how does this compare to other celestial objects? While black holes and neutron stars also have magnetic fields, magnetars stand out for their strength. In fact, one could say they are the champions of magnetism in the universe. Now, what does this mean for the environment surrounding a magnetar? Imagine you are in a park and feel a gust of wind. That breeze can move leaves and branches, but what happens near a magnetar is much more drastic. Charged particles in its vicinity are dragged and accelerated to extraordinary speeds. This not only creates visually stunning phenomena, but also causes emissions of X-rays and gamma rays that can be detected thousands of light years away. The energy released by a magnetar is so intense that it can be compared to cosmic explosions. Some of these explosions are so powerful that they can be seen from Earth. But what kind of impact do these explosions have on daily life? Fortunately, magnetars are so far from us that their effects are not an immediate concern. However, if one were closer, the radiation could be dangerous, even potentially devastating for our planet. The way a magnetar generates its extreme magnetic field is fascinating. It is believed that this field originates from the rapid rotation of the object and the intense pressure inside it. As it spins, the magnetar acts like a gigantic dynamo, generating a magnetic field that defies all logic. This may sound like science fiction, but it is simply physics in action in its most extreme form. The mystery of magnetars does not stop at their magnetic field. What happens when a magnetar begins to lose energy? Over time, its magnetic field can weaken, and this can lead to a change in its behavior. But what does that imply for its lifespan? The life of a magnetar can be relatively short in astronomical terms, lasting only a few thousand years before its powerful energy runs out. The fascination with magnetars also lies in their uniqueness. If we consider the number of stars in our galaxy, the number of magnetars is quite small, making them rare and special objects. Each one is a reminder of the extremes that nature can reach. The rarity of these objects makes them even more intriguing for astronomers and scientists seeking to understand the secrets of the universe. There are even theories suggesting that the magnetic field of a magnetar could be strong enough to affect the behavior of matter in its proximity. This raises questions about how magnetars might influence the formation of stars and planetary systems around them. Could they even be the key to understanding certain astrophysical phenomena that we have yet to fully decipher? The exploration of magnetars has led to great advances in modern astrophysics. Each discovery about their extreme magnetic fields brings us a little closer to understanding the mysteries of the cosmos. So the next time you look up at the sky and wonder about the secrets it holds, remember that there are magnetars out there spinning and generating magnetic fields that challenge the imagination. The study of these phenomena not only expands our knowledge of the universe, but also helps us better understand the very nature of reality. Magnetars are a perfect example of how what seems incredibly distant and strange can have repercussions on our understanding of life and the cosmos. Science continues to advance, and each new finding about magnetars reminds us that the universe is a place full of surprises. waiting to be explored. Magnetars are an extraordinary type of neutron star, but did you know that not all magnetars are the same? In fact, there is a fascinating classification that helps us better understand their properties and behaviors. The diversity of these cosmic bodies is so astonishing that each one has its own story to tell. First, let's talk about rotation magnetars. These are the most well-known, and as their name suggests, they spin rapidly on their axis. Imagine a spinning top. The faster it spins, the more energy it has. The same goes for these magnetars. Their extreme rotation generates an incredible amount of energy, resulting in X-ray and gamma-ray bursts that are so intense they can be detected millions of light-years away. Their energy is comparable to that of several million suns combined, a true cosmic spectacle. On the other hand, we find field magnetars. Although they are also neutron stars, their most prominent feature is not so much their rotation but the powerful magnetic field they generate. This field is so strong that it could warp the space-time around it, as if a gigantic magnet were pulling everything in its path. Can you imagine having a magnetic field that can alter the course of celestial objects? A true feat of the universe. The classification of magnetars is based on their behavior and physical properties, but there are also other factors that influence it. For example, the chemical composition of a magnetar can determine how its characteristics manifest. Some may have a denser core which can affect their magnetic field and the way they emit radiation. It's as if they have unique personalities depending on their formation and evolution. The duration of their activity cycles is also a crucial aspect of this classification. Some magnetars may be inactive for years, while others may experience more frequent outbursts. This variability gives us clues about the internal processes occurring in these celestial bodies and, in turn, raises intriguing questions about how they behave over time. What factors determine when a magnetar decides to wake up and emit its energy? An interesting fact is that rotation magnetars tend to be younger than their field counterparts. This is because by spinning rapidly, their energy dissipates more quickly, shortening their lifespan. But what happens when a rotation magnetar becomes a field magnetar? This transition is a mystery that astrophysicists are trying to unravel, as it could reveal information about the evolution of these massive stars. Moreover, magnetars can exhibit different types of emissions depending on their classification. Rotation magnetars typically emit regular pulses of X-rays, while field magnetars may have more erratic emissions. This variability in emissions can offer clues about their internal structure and the dynamics of their magnetic field. Each flash of light we observe from Earth could be a message from the past of these celestial bodies. Curiosity doesn't stop there. As we delve deeper into the study of magnetars, we also find that their classification can influence their impact on the environment. For example, a rotation magnetar with intense activity could have a much more dramatic effect on the surrounding space than a relatively inactive field magnetar. Let's consider how these phenomena affect nearby stars and planets. A rotation magnetar could, in theory, influence the formation of new stellar systems, while a field magnetar could affect the dynamics of the stars in its vicinity. Who would have thought that such a distant object could play such an important role in the ecosystem of the universe? As scientists continue to classify and study these fascinating bodies, it becomes evident that each magnetar is a cosmic puzzle. Classification not only helps to understand their characteristics, but also opens the door to new questions. What other types of magnetars might exist? Are there variations that we have yet to discover? Exploring these mysteries is what drives astrophysical research forward. The classification of magnetars is not just an academic exercise, it is a way to connect humanity with the cosmos. It reminds us that, although we are in a small corner of the universe, there are extraordinary phenomena that invite us to keep investigating, learning, and marveling. Each magnetar is a story waiting to be told, and we are the narrators of this cosmic epic. So, the next time you look up at the sky and think about the stars, remember that among them are magnetars, those magnetic titans that teach us about the limits of the universe and the incredible diversity of what exists within it. The classification of these bodies is not just a detail, it is the key to unraveling the secrets of the cosmos. With each new observation, each new classification, we are one step closer to understanding the immense beauty and complexity of the universe we inhabit. The X-ray and gamma emissions from magnetars are a fascinating phenomenon that has captured the attention of astronomers and scientists around the world. But what does this really mean? To understand it, we must first remember that magnetars are neutron stars with extremely powerful magnetic fields, and this has a direct impact on how they emit radiation. In the vast universe, these emissions are like the bright lights of a cosmic party that illuminate space and tell us stories about the extreme behavior of matter. Imagine you are in a dark room. Suddenly, someone turns on a powerful laser that cuts through the darkness, creating dazzling patterns of light. This is how magnetars work, but instead of a simple laser, they are projecting X-rays and gamma rays, which are forms of highly energetic radiation. But how do we know they exist, and how do we detect them? The answer lies in our space telescopes, which are like enormous eyes that can see beyond what our human eyes can capture. Telescopes like Chandra and Fermi are designed to observe these emissions. When a magnetar releases its energy, it emits bursts of gamma rays that are thousands of times more powerful than any other source in the universe. These flashes are so intense that they can be detected millions of light years away, allowing us to study these phenomena even from here in our small corner of the galaxy. One of the most intriguing questions is, why does a magnetar emit X-rays and gamma rays in the first place? The answer lies in the instability of its magnetic field. This field is so strong that it can cause enormous releases of energy, resulting in bright explosions that are often brief but extremely powerful. Every time one of these explosions occurs, it's as if the magnetar is sending a message to the universe, a message that helps us better understand the nature of matter and the forces that govern the cosmos. Moreover, these explosions are not just an isolated phenomenon. They occur in cycles, meaning a magnetar can be calm for a while and then suddenly release huge amounts of energy. This erratic behavior adds another layer of mystery to its study. Scientists are working hard to create models that explain why and when these explosions occur. It's like trying to predict the weather, but instead of rainstorms, we are talking about storms of cosmic energy. Magnetars are also a reminder of how small we are compared to the universe. A single gamma ray burst from a magnetar can release more energy than our sun will emit in its entire lifetime. This incredible amount of energy makes us rethink what we know about physics and astrophysics. What other secrets might be hidden in the vast universe waiting to be discovered? Speaking of secrets, some scientists believe that magnetars could be the key to understanding even stranger phenomena, such as the gamma ray bursts we observe from Earth. These bursts are cataclysmic events that may be caused by magnetars, and by studying their emissions, we can unravel the mystery of these events. It's like dismantling a cosmic puzzle, where each piece we fit together brings us closer to the complete picture. As we delve deeper into the study of magnetars, we also begin to see connections with other astrophysical phenomena. For example, it has been suggested that magnetars could be related to the formation of certain types of galaxies. This tells us that the impact of these neutron stars goes beyond their own existence. They are intertwined in the very structure of the universe itself. An exciting part of this research is the possibility that magnetars may help us better understand fundamental physics. The extreme conditions found in these objects can offer clues about how forces work in the universe. Essentially, magnetars are natural laboratories that allow us to explore the limits of physics. What other secrets of nature could be revealed by studying these fascinating objects? However, not everything emitted by magnetars is destructive. They can also offer opportunities for technological advancement. Research into X-ray and gamma radiation could lead to innovations in the field of medicine, such as the creation of better medical imaging systems. Thus, what seems to be a distant phenomenon unrelated to our daily lives may have practical applications that impact our everyday existence. Finally, It is essential to remember that every time a magnetar emits X-rays or gamma rays, it is sending a signal to the universe. These emissions are like an echo of its existence, a beacon in the darkness of space. Every flash we observe reminds us that there is much more in the cosmos than we can see or comprehend. And although we are still in the early stages of our journey to understand magnetars, each discovery brings us closer to unraveling the mysteries of the universe. So the next time you look up at the starry sky, remember that there are immense and mysterious forces at play, and that magnetars with their powerful X-ray and gamma emissions are one of the many wonders that invite us to keep exploring and learning more about the vast and enigmatic universe we inhabit. Magnetars are fascinating objects, but their influence is not limited to themselves. Imagine a drum that, when struck, not only produces a sound but also generates waves that affect everything around it. This is how magnetars interact with their environment. Their magnetic field is so powerful that it affects not only other stars but also space itself. What happens when a magnetar is surrounded by other stars? The answer is that its presence can alter the trajectory of these celestial bodies. If we think of a magnetar as a giant magnet, we can imagine that its force can attract or repel other stars and matter nearby. And what about the planets that orbit close to a magnetar? The extreme radiation emitted by these objects can be devastating, with potentially catastrophic effects. Magnetars release enormous amounts of energy in the form of X-rays and gamma rays, which travel through space like arrows in a vast cosmic ocean. When this radiation reaches other stars or planets, it can cause changes in their atmospheric composition, even in their very structure. Can you imagine what it would be like to live on a planet that orbits near a magnetar? Life, as we know it, could be unsustainable due to the intense radiation. At the heart of this interaction lies the phenomenon of gamma-ray bursts. These bursts are like flashes of light that illuminate the universe and are often associated with events related to magnetars. The energy released in these events is unimaginable and can be detected billions of light years away. What impact would such an explosion have on a nearby planet? The answer could be a catastrophic change on its surface. Proximity to a magnetar can also influence the formation of new stellar systems. With such intense gravitational force, these objects can attract gas and cosmic dust, creating conditions that may lead to the formation of new stars. Could a magnetar be the catalyst for the creation of new constellations? The answer is a fascinating yes under certain circumstances. The energy emitted by magnetars can even affect dark matter and dark energy, mysterious components of the universe that we do not yet fully understand. This influence could provide clues about the very nature of the cosmos. What mysteries could be revealed if we manage to understand how magnetars interact with these invisible elements? Each magnetar is unique, and therefore its imprint on space is too. Some magnetars may emit regular pulses of energy, while others may exhibit more erratic behavior. This variability can influence how other celestial bodies respond to their presence. Is it possible that magnetars act as beacons in the universe, guiding other objects around them? In a broader sense, the existence of magnetars reminds us of how interconnected the universe is. Just as a stone thrown into water creates ripples on the surface, the existence of a magnetar can have repercussions across a vast range of cosmic phenomena. Understanding these effects can offer a new perspective on how the universe operates on a large scale. Every discovery about magnetars also leads us to question what we already know. Research on how they affect their environment can open new avenues for understanding other astrophysical phenomena. What other surprises might await astrophysicists studying these peculiar stars? Moreover, the influence of a magnetar is not limited to physical space. It can also have effects on radio waves and other types of radiation that reach our planet from space. These cosmic flashes can be a window into the unknown, revealing secrets of the universe that remain hidden. Life as we know it is deeply connected to the environment around us, and magnetars are a reminder that there are forces far beyond our control. The way these extreme objects affect their surroundings and other celestial bodies invites us to reflect on our own existence in the vast universe. We can think of magnetars as the titans of the cosmos, whose actions reverberate through space and time, creating a cosmic ecosystem that goes beyond what we can see. How many wonders and mysteries lie hidden in the vastness of the universe, waiting to be discovered? The answer lies in our curiosity and desire to explore the unknown. Therefore, as we look up at the sky, let us remember that each star, each phenomenon, and each magnetar has a story to tell. These objects are not only fascinating in themselves, but also key pieces in the puzzle of the universe. Exploring their influence on the surrounding space is just the beginning of a journey toward a deeper understanding of the nature of the cosmos. Neutron stars are one of the most fascinating phenomena in the universe, but what exactly are they? Imagine that at the end of the life of a massive star, it explodes in a supernova, releasing an impressive amount of energy. What remains after that explosion is a compact star that has collapsed so much that its matter has become incredibly dense. In this process, the star has compressed its core to such an extent that a teaspoon of its matter could weigh as much as a mountain. Now, what are the characteristics that make a neutron star so special? To understand this, we first need to talk about the composition of these stars. They are primarily made up of neutrons, which are subatomic particles that have no electric charge. Compared to protons and electrons, neutrons are like the ninjas of the atomic world, silent but incredibly powerful. This extreme density means that neutron stars are some of the densest structures in the universe. An intriguing aspect of neutron stars is their size. Even though they contain a mass comparable to that of the Sun, their diameter is only about 20 kilometers. To put this in perspective, imagine a sphere the size of a city, but with the mass of a giant star. That extreme compression is what gives them their incredible gravity. The gravitational force on the surface of a neutron star is many times stronger than that of Earth, so any object that falls onto it would be instantly crushed. But how are neutron stars related to magnetars? Both are the result of the collapse of massive stars, but there is a key difference. Magnetars are a special type of neutron star that are not only incredibly dense but also possess extremely powerful magnetic fields, millions of times stronger than those of a typical neutron star. This magnetic field is so intense that it can affect the matter around it, creating fascinating phenomena in space. The formation of a neutron star, and thus a magnetar, occurs at the end of the life cycle of a massive star. When the star exhausts its nuclear fuel, it can no longer support itself against gravity. This collapse triggers a violent explosion known as a supernova. What remains is a star that has been compressed to an incredibly small size. However, not all neutron stars become magnetars, only those born under specific conditions where the magnetic field intensifies during the collapse process. But what is the importance of studying these neutron stars? Understanding how they form and what distinguishes them from other celestial bodies helps us unravel the mysteries of the universe. Neutron stars, and particularly magnetars, are natural laboratories that allow us to study physics under extreme conditions, something we cannot replicate here on Earth. This has profound implications for our understanding of fundamental physics, gravity, and matter. Moreover, by studying neutron stars, we are also looking towards the future. We wonder what will happen to the stars in our own solar system, and beyond that, what implications will the existence of these strange and powerful objects have for life on our planet? If a magnetar were ever to come too close to Earth, the consequences could be catastrophic. The relationship between neutron stars and magnetars also leads us to think about the diversity of the cosmos. Within the vast universe, each object has its own story and unique characteristics. Neutron stars, with their incredible density and extraordinary properties, are a reminder of how little we truly know about space. As we explore these phenomena, each new revelation leads us to more questions, fueling our curiosity and desire to learn more. In summary, neutron stars are much more than mere remnants of dead stars. They are complex entities that offer us a window into the physics of the universe at its extremes. With each discovery, astronomers get a little closer to understanding not only these strange stars, but also the very nature of the cosmos. The exploration of neutron stars and magnetars is a journey we have only just begun, and each new finding can change our perspective on what is possible in the universe. Following this line of thought, it is fascinating to imagine how these stars, despite their remoteness and extreme nature, are intimately linked to the history of our own world. The quest for answers about neutron stars is ultimately a quest for our place in the vast universe. Have you ever heard of pulsars and wondered what makes them different from magnetars? While both are types of neutron stars, there are some fascinating differences that distinguish them. Let's start by understanding what a pulsar is. A pulsar is a neutron star that emits electromagnetic radiation periodically, like a cosmic lighthouse blinking in the vast ocean of space. But what about magnetars? Magnetars, on the other hand, are a special type of neutron star. But with a characteristic that makes them unique, their magnetic field is extremely powerful, much more so than that of a pulsar. Imagine a magnet so strong that it could affect everything that comes near it from unimaginable distances. That is the strength of a magnetar. Its magnetic field can be 1,000 billion times stronger than that of an ordinary magnet. To put it in more concrete terms, it is equivalent to the power of 1,000,000 Earth magnetic fields combined. But how does this difference manifest in their behavior? While pulsars rotate and emit radiation regularly, creating a rhythmic pattern that we can measure, magnetars are more erratic. Their radiation emission can be explosive and chaotic, like a volcano suddenly erupting. This is because in their core the conditions are so extreme that their energy is released unpredictably, sometimes in the form of bursts of X-rays or gamma rays. Some might wonder, why are these differences so important? Understanding how magnetars and pulsars work helps us unravel the mysteries of the universe. For example, pulsars are used by scientists as cosmic clocks thanks to their precision in emitting signals. In contrast, magnetars, with their powerful magnetic field, are natural laboratories for studying physics under extreme conditions. They allow us to investigate phenomena that we cannot recreate on Earth. The life of a magnetar is also different from that of a pulsar. Magnetars are believed to have a shorter lifespan, often only a few thousand years, compared to pulsars that can exist for millions of years. This is because their energy is consumed quickly, especially when they release those bursts of radiation. So while a pulsar may be blinking for eons, a magnetar may have a shorter life cycle, but no less impactful. When we think of magnetars and pulsars, it is important to remember that both are part of the same family, but they have very different personalities. Pulsars are stable and predictable, while magnetars are unpredictable and explosive. This variety in the behavior of neutron stars offers us a more complete view of stellar life cycles and the processes that govern the universe. What about their environment? Magnetars not only affect their own existence, but their intense magnetic field can influence the space around them. Imagine being near a magnetar. The strength of its field could bend the path of light or even affect the movement of nearby stars. This makes their study crucial for understanding the dynamics of the cosmos. The comparison between magnetars and pulsars also leads us to explore their role in the evolution of galaxies. Pulsars can be considered as the lighthouses illuminating the way in the darkness of space, while magnetars could be seen as the fireworks exploding in the sky, leaving a trail of energy that can be detected from great distances. In conclusion, although magnetars and pulsars are both fascinating and extraordinary, their differences are a testament to the diversity of the universe. Each in its own way tells us a story about physics, energy, and the cosmic processes that shape our world. By studying these neutron stars, we get a little closer to understanding the secrets of the universe and our place in it. So the next time you look up at the starry sky, remember that there is more to those distant lights than meets the eye, and that magnetars and pulsars are just two of the many characters in this vast cosmic story. The lifespan of a magnetar is one of those fascinating mysteries that continues to intrigue scientists. How long does a magnetar live before its powerful magnetic field fades? The answer to this question is not straightforward, but an analogy can be made with a lighthouse in the midst of a storm. A lighthouse can shine brightly, guiding ships to safety, but over time, its light goes out if it is not provided with fuel. Magnetars, although they are some of the most enigmatic objects in the universe, also have a limited period of activity. Generally, it is estimated that a magnetar has a lifespan of around 10,000 to 1,000,000 years. This may seem like a long time on our human scale, but in the vast universe it is a whisper. During this lifespan, the magnetar experiences a series of events that can affect its energy and, consequently, its luminosity. As its energy is consumed, its magnetic field begins to weaken. What causes this loss of energy? The answer lies in the instability and internal dynamics of these stars. Throughout its life, a magnetar may witness a series of gamma-ray bursts. These explosions are like cosmic fireworks, emitting enormous amounts of energy in an instant. However, each explosion is also a sign that the magnetar is depleting its energy reserves. Imagine that each explosion is a flash of light that slowly fades, leaving the magnetar weaker and more vulnerable to eventual extinction. The intense magnetization of a magnetar has interesting effects on its environment. As its magnetic field breaks down, phenomena such as radiation emission occur, and the area surrounding the star begins to change. This can result in a series of interactions that affect not only the magnetar, but also the celestial bodies that orbit around it. Who would have thought? The life of a magnetar not only affects its own fate, but also that of other cosmic objects. Magnetars are often considered the rock stars of neutron stars. Their lifespan is brief compared to other stars, but during that time, they are capable of generating more energy than millions of stars in our galaxy. Each magnetar is a spectacle of lights and sounds, but eventually its energy fades like a show coming to an end. This raises an intriguing question. What exactly happens when a magnetar definitively shuts down? One of the most accepted theories suggests that, at the end of its life, a magnetar could become a normal neutron star. However, this process is not so simple. The magnetar does not transform immediately. Instead, it goes through a cooling phase, during which its magnetic field becomes weaker and its activity decreases. This cooling period can take thousands of years, but eventually the star becomes a more inert object in the cosmos. However, what happens after a magnetar shuts down is a fascinating field of study. Some scientists believe that these objects could leave behind remnants that might be detectable for millennia. In fact, it has been speculated that some of the magnetars we know today may actually be the dead versions of magnetars that once shone brightly in the universe. Another intriguing question is whether a magnetar can reactivate after losing its energy. The answer is somewhat uncertain. Some researchers believe that, under very specific conditions, a magnetar could experience a resurrection of its activity. But this is still a largely unexplored area filled with unknowns. In the scientific community, the lifespan of a magnetar is not only a topic of interest in itself, but it also has broader implications for the evolution of massive stars and their influence on the formation of new stellar systems. By studying how and when magnetars die, astronomers can better understand the life cycle of stars and their impact on the universe. Therefore, the life of a magnetar, although brief, is a phenomenon that teaches us much about the nature of the cosmos. Each magnetar tells a story of creation, energy, and eventually extinction. And although these objects are ephemeral, their study opens a window to the understanding of astrophysics as a whole. So the next time you look up at the sky, remember that, although magnetars are distant and mysterious objects, their life and death are part of a cycle that shapes our universe. In the vastness of our Milky Way, magnetars can be found, those enigmatic objects that challenge our understanding of the universe. But how many of them really exist in our galaxy? The answer is not as straightforward as it seems. Astronomers have identified around 24 confirmed magnetars in the Milky Way. However, there is an exciting possibility that many more exist, hidden in the vast ocean of stars and dark matter that surrounds us. Imagine you are on a beach, and each wave that reaches the shore represents a star. Most of these stars are like lighthouses in the distance, bright and familiar, but among those waves there are some that are extraordinary. Like magnetars, each one is unique with its own story and characteristics, but they all share a common bond, their origin in violent supernova explosions. The distribution of magnetars in our galaxy is not random. They are primarily found in regions where there has been intense stellar activity, such as in young clusters where stars are born and die in dizzying cycles. But why is it important to know their location? The answer lies in the effects they can have on their surroundings. The intense gravity and magnetic field of a magnetar can influence the trajectories of other stars and the formation of new stellar systems. One fascinating aspect is that although there is a limited number of confirmed magnetars, it is estimated that there could be hundreds of them in our galaxy. This is because many may be too faint to be detected with our current telescopes. It's like having a big party in a dark room. You can see some guests, but others might be in dark corners waiting to be discovered. Observing magnetars is a challenge. Their light is often dim and faint, and their X-ray and gamma radiation, while powerful, can be difficult to capture. However, astronomers use advanced technologies such as space telescopes to search for these signals. It's a bit like fishing in the ocean. Sometimes the line doesn't bite, but with patience and the right technique, something extraordinary can be caught. As scientists continue to explore the Milky Way, they are beginning to better understand how magnetars are distributed. They have been observed to be more concentrated in the densest regions of the galaxy, where gravitational interactions are more frequent. This gives them a special place in the fabric of the cosmos, acting as beacons that illuminate the history of star formation. The question of how many magnetars are in the Milky Way also opens the door to investigating their origin. Could there be different families of magnetars, each with its own history and evolution? Some scientists believe they may have formed from different types of supernovae. Imagine a kind of cosmic family tree where each magnetar is a branch that grows and bifurcates, telling the story of its birth. Magnetars are not only fascinating for their quantity and distribution, but also for the effects they have on their surroundings. Their powerful magnetic field can impact nearby stars, affecting their formation and evolution. Astronomers are increasingly interested in how these giants can influence the lives of other stars, creating a dynamic and ever-changing stellar ecosystem. Moreover, the research on magnetars is helping scientists to better understand the life cycle of stars. Each discovery about a magnetar can lead to new questions about how stars are born, live, and die in our galaxy. It's like a cosmic puzzle where each piece has a greater significance. The search for magnetars also has implications beyond our galaxy. By studying how they are distributed in the Milky Way, astronomers can make conjectures about the existence of magnetars in other galaxies. This could help reveal patterns in galaxy formation and the evolution of the universe, a window into the cosmic past. Finally, the intriguing question of magnetars in the Milky Way reminds us that there is still much to learn about our universe. Each discovery raises new questions, and each answer brings us one step closer to understanding the mysteries of the cosmos. So, as we continue to search, each magnetar we find becomes a beacon of knowledge, illuminating not only its history but also ours in this vast universe. How can we detect something as distant and mysterious as a magnetar? The answer to this question leads us to explore a fascinating world of technology and scientific curiosity. Magnetars, with their intense magnetic fields and emissions of X-rays and gamma rays, are not easy to observe, but astronomers have developed ingenious methods to study them. The first tool in this journey of discovery is X-ray observation. Imagine you're in a dark room and suddenly someone turns on a powerful flashlight. The light disperses and reveals hidden details that you couldn't see before. Similarly, magnetars emit X-rays that, when captured by specialized telescopes, provide us with vital information about their nature. These telescopes are like large eyes in the sky, capable of detecting radiation that our eyes cannot see. But what happens when a magnetar releases an explosion of energy? This is another key to its detection. The energy released during these events can be comparable to that of billions of suns. Like a lighthouse flashing in the distance, these explosions shine brightly in the gamma-ray spectrum. Gamma-ray observatories, such as the Fermi Space Observatory, are capable of capturing these bursts, allowing scientists to study the behavior of these fascinating objects. The analysis of radio waves also plays a crucial role in the detection of magnetars. Think about how sound waves travel through the air. Radio waves do the same, but through space. When a magnetar spins, it can emit pulses of radio waves that resemble a rotating beacon. These pulses can be captured by radio telescopes on Earth, providing us with more information about its rotation and magnetic field. Optical telescopes, although not the primary tool for studying magnetars, also have their importance. While visible light is opaque to the powerful radiation of a magnetar, some telescopes can capture the light that escapes. This allows astronomers to observe the environment of the magnetar and how it interacts with its surroundings, providing valuable context about its formation and characteristics. Collaboration between different types of telescopes is fundamental. By combining data obtained from X-rays, gamma rays, and radio waves, scientists can build a more complete picture of what is happening at the heart of a magnetar. It's like assembling a puzzle with pieces of different colors and shapes. Each piece provides unique information that helps complete the image. With the advancement of technology, detection methods have become increasingly sophisticated. For example, satellites orbiting Earth are equipped with instruments that can detect high-energy radiation, allowing real-time observations of events occurring in space. This has changed the way we study magnetars, making us more aware of their activity and impact on the cosmos. But why is it so important to study magnetars? The answer lies in the impact these objects have on our understanding of the universe. By studying their properties, we can learn more about the extreme physics that governs the behavior of matter under extreme conditions, something we cannot replicate on Earth. Each discovery about a magnetar can open new doors in astrophysical research. And what about the role of scientists in this process? They are the modern explorers, using technology as their ship and data as their map. With each new observation, they embark on a journey into the unknown, unraveling the mysteries of the universe and sharing their findings with the world. The passion for discovery drives their work, and each studied magnetar is another piece in the vast puzzle of the cosmos. The formation of collaborative networks among scientists from different institutions and countries has also facilitated the study of magnetars. By sharing data and resources, researchers can leverage the expertise of others and advance more quickly in their discoveries. This spirit of collaboration is essential for progress in astrophysics and reminds us that despite the distance that separates us from the universe, we are all connected in our quest for knowledge. As we look to the future, it is clear that the detection and study of magnetars will continue to evolve. New technologies such as more powerful telescopes and advanced satellites promise to take our understanding to even deeper levels. Each new advance brings us closer to unraveling the secrets of these mysterious objects and their role in the history of the universe. Human curiosity is insatiable, and every answer we find leads us to new questions. Magnetars, in their strange and spectacular nature, are a reminder of how little we know and how much there is to discover in the vast ocean of the cosmos. With each new discovery, we open the door to a world of possibilities and take one step closer to understanding our place in the universe. Thus, the search for magnetars is not just a scientific exercise. It is an adventure that invites us to look up, to question what we see, and to marvel at the grandeur of the universe that surrounds us. With each pulse of a magnetar, we are reminded that there is so much more beyond our world, waiting to be discovered. In the vast universe of astrophysics, magnetars have emerged as true cosmic wonders, challenging our understanding and raising new questions. Why are they so important in the study of the cosmos? The answer lies in their extraordinary nature. Despite being a type of neutron star, magnetars possess extremely powerful magnetic fields and radiation emissions that can illuminate parts of the universe that would otherwise remain in darkness. But what does this mean for scientists? Simply put, magnetars are natural laboratories where the laws of physics can be explored under extreme conditions. The first big question that arises is, how do magnetars influence our understanding of the universe? As astronomers study these objects, they encounter phenomena that cannot be replicated on Earth. Magnetars, due to their intense gravity and unparalleled magnetism, allow scientists to test theories about matter, energy, and fundamental forces. In this sense, each new observation of a magnetar offers an opportunity to adjust or even revolutionize our existing theories. Another intriguing question is, what role do magnetars play in the evolution of galaxies? Their incredible energy not only impacts their immediate surroundings but can also influence the formation of new stars. When a magnetar emits radiation in the form of gamma-ray bursts, the energy released can affect the gas and dust surrounding the star, potentially triggering the creation of new stars. Thus, magnetars are not only objects of study but also key players in the cosmic theatre. But what about their relationship with other objects in the universe? Magnetars are a crucial link in the chain of events that lead to the creation of other astronomical phenomena. For example, some of the most powerful gamma-ray bursts are thought to be related to magnetar activity. These bursts are explosions of energy that can rival the light of billions of stars. Understanding how magnetars are connected to these events helps us unravel the mysteries of the universe. Despite their distance, magnetars have a direct impact on our understanding of life on Earth. There has been speculation about how a nearby gamma-ray burst could affect our planet. Although such events are rare, the possibility that a nearby magnetar could generate a phenomenon that alters life on Earth serves as a reminder of how interconnected everything is in the universe. This leads us to wonder, how much do we really know about the dangers and wonders that surround us? Research on magnetars has also revealed fascinating data about matter in extreme states. Current theories suggest that at the heart of a magnetar, matter behaves in ways we have never seen on Earth. This leads us to ask, what secrets does matter hold under those conditions? Each discovery about magnetars could have profound implications for our understanding of physics. One of the most fascinating aspects of magnetars is their ability to generate gravitational waves. These echoes of the universe traveling through space-time offer a new way to observe the cosmos. The detection of gravitational waves has opened a new field of study in astrophysics, and magnetars are a key component in this narrative. The question that arises here is, what other secrets might be revealed by studying the gravitational waves generated by these objects? As scientists develop new technologies to observe magnetars, they are also pushing the boundaries of what we believe is possible. The combination of cutting-edge telescopes and innovative methods is allowing astronomers to gather more precise and detailed data. This raises an intriguing question. What unexpected discoveries await us in the future as we advance our ability to study the universe? The importance of magnetars goes beyond their individual study. Research on these objects also fosters international collaboration among scientists, from using telescopes in different parts of the world to creating networks of researchers who share data and findings. The study of magnetars is bringing together brilliant minds from around the globe. Isn't it amazing to think how the study of a distant star can unite people from different cultures and disciplines? On a more philosophical level, magnetars invite us to reflect on our own existence. By exploring how these cosmic objects influence their surroundings and the universe at large, we confront questions about our place in the cosmos. What does it mean to be part of a universe where the most extraordinary phenomena can impact life itself? This connection reminds us that while we are small compared to the vastness of the cosmos, we are part of a larger story. Finally, as we continue to unravel the mysteries of magnetars, we are reminded that the universe is a place full of surprises. Each discovery brings new questions and new directions for research. With each magnetar we study, we are one step closer to understanding not only these fascinating objects, but also the very fabric of the universe in which we exist. The exploration of magnetars, therefore, is not just a journey into the unknown, but a journey to the heart of what it means to be human in an immense and wondrous cosmos. Magnetars are some of the most intriguing phenomena in the universe, but which ones are the most famous and what makes them unique? Today we will take a journey through some of these cosmic titans that challenge our understanding of physics. We begin with one of the best-known magnetars, the magnetar called 705. This object is located approximately 1,600 light-years from Earth. What makes it so singular is its magnetic field, which is incredibly 1,000 times more powerful than that of a typical pulsar. Imagine a magnetic field so strong that it could tear apart the structure of a common object like a car, and that from millions of kilometers away. It is undoubtedly a reminder of how small and insignificant our planet can be compared to these giants. Another famous magnetar is known as 109. This magnetar not only has an impressive magnetic field, but is also known for its X-ray bursts. These bursts are so powerful that if they occurred at a much closer distance, they could be devastating for any form of life. Fortunately, 109 is located more than 10,000 light-years away from us. But what would happen if a magnetar were closer? The answer is that life on Earth could be severely affected, and that is something scientists study with great interest. On the list of interesting magnetars is the one called 122. This magnetar is a perfect example of how these stars can alter their environment. Its X-ray emissions are not only intense, but can also influence the formation of gas and dust clouds around it. Imagine these cosmic explosions as fireworks in space, creating an impressive visual spectacle while also altering the stellar landscape. The interaction of a magnetar with its environment is a phenomenon that continues to fascinate astrophysicists. On the other hand, we have the magnetar 141, which is known for its mysterious activity and for being one of the most studied in our galaxy. This magnetar has shown emission patterns that are difficult to predict, making it a true puzzle for scientists. What drives these changes in its behavior? We do not yet know for sure, but each new discovery about its activity brings us one step closer to better understanding these enigmatic objects. It is also worth mentioning the magnetar 152, which has been the subject of several recent investigations due to its unusual gamma-ray emissions. These bursts are so powerful that when detected, they send waves of energy through space. Imagine each gamma-ray explosion as a heartbeat of a star, and each heartbeat can be detected thousands of light-years away. This is not only astonishing, but also helps us learn more about the structure and dynamics of our universe. Magnetars are not only famous for their energy and explosions, but also for how they challenge our current theories. For example, the magnetar 153 has led scientists to revise their ideas about stellar evolution. Its existence raises questions about how these objects form and evolve, and whether there are more in the universe that we have yet to discover. The magnetar 160 stands out for its peculiar behavior. It has shown bursts of activity that can last for days, which is unusual compared to other magnetars. Why does it have such a prolonged activity cycle? Scientists continue to investigate, trying to unravel its secrets and understand how these cosmic giants behave. Some magnetars, like 171, are famous not only for their magnitude but also for the challenges they present in terms of detection. This magnetar is located in a dense region of our galaxy, making it difficult to study. However, its influence on the surrounding space is notable, and astronomers have found ingenious ways to detect it despite the difficulties. It is a testament to the tenacity of scientists in their quest for knowledge. And we cannot forget the magnetar 108, which has been thoroughly studied due to its relationship with gamma-ray bursts. This object has been fundamental in understanding how magnetars can trigger such energetic events. Every time an explosion is detected, scientists rush to gather data that can shed light on the mechanism behind these eruptions. The fascination with magnetars also extends to their history. Over the years, we have learned more about them thanks to technological advancements. The magnetar 110, for example, was identified relatively recently, and its discovery has opened new doors in our understanding of the universe. Each new magnetar we find is like a new chapter in a cosmic book that is still being written. Finally, we cannot overlook the magnetar 109, which has captured the attention of researchers due to its uniqueness. This object has shown characteristics that challenge preconceived notions about magnetars, leading us to question what we know. This is how science advances, pushing the boundaries of our understanding and presenting new questions that invite exploration. These are just a few examples of the magnetars that inhabit our galaxy, each with its own story and peculiarities. Researching them not only helps us better understand these extraordinary phenomena, but also offers us a window into the nature of the universe we live in. In the end, magnetars are a reminder that there is still much to discover in the cosmos, and that every answer we find can lead us to new questions and adventures. Theories about magnetars are a fascinating maze of ideas and concepts that have sparked the curiosity of scientists and space enthusiasts alike. What truly makes these objects so extraordinary? The answer is not simple, and that is what makes it even more intriguing. Magnetars are, in essence, neutron stars with extremely intense magnetic fields, but their origin and functioning are a true enigma. One of the most pressing questions about magnetars is, how do they manage to have such powerful magnetic fields? Current theories suggest that their extraordinary magnetic strength is formed during the collapse of a massive star, when the core collapses and becomes a neutron star. However, it is not just the collapse that generates a magnetar. The conditions must be particularly suitable. It is believed that the rapid rotation of the star and certain dynamo processes could be key factors in this formation. What about the energy they emit? It has been suggested that the energy released from these stars is so intense that it could rival the energy of a supernova. This astonishing phenomenon has led scientists to investigate how these bursts of energy are generated. Some believe that the internal movement of plasma and the magnetic field, which behaves almost like an electrical conductor, could be responsible for this release of energy. Another fascinating aspect of magnetars is their relationship with gamma-ray bursts. Why do these powerful events occur? Theories suggest that magnetars could trigger gamma-ray bursts by releasing energy accumulated in their magnetic field. Imagine an extremely tense spring that is released all at once, producing a burst. That is the idea behind how a magnetar could generate gamma rays. The interactions between particles in the magnetic field of a magnetar are another point of interest. How do these particles influence the radiation they emit? It has been theorized that charged particles in the plasma can be accelerated to incredible speeds, resulting in the emission of high-energy radiation. This phenomenon has led scientists to further investigate the physics behind these processes, opening new doors in the understanding of the universe. However, not all magnetars are the same. There are variations in their properties that have led to different theories about their nature. Some theories suggest that there are two main types of magnetars: those with a more stable magnetic field and others that experience fluctuations in their intensities. This raises the intriguing question: what determines that stability? Observations of magnetars have also fueled the debate about their lifespan. How long can a magnetar exist before its energy runs out? Scientists believe that the lifespan of a magnetar may be relatively short in cosmic terms, perhaps only a few thousand years compared to other stars that can shine for millions of years. However, this has not prevented their study from continuing, as each magnetar is a window to better understand the life cycle of stars. Moreover, magnetars have been key in the development of new theories about particle physics. How can such a small object, in comparison to its power, offer so many clues about the universe? The answer lies in the fact that magnetars are natural laboratories that allow scientists to study extreme phenomena that cannot be replicated on Earth. This has led to significant growth in the understanding of physics under extreme conditions. As new technologies are developed and more advanced telescopes are built, more magnetars are expected to be discovered. And theories about them will expand. What other secrets could be unveiled with these new findings? The possibility that there are magnetars we have yet to detect is exciting, and each new discovery could change our understanding of physics and the cosmos. Finally, theories about magnetars also lead us to reflect on humanity's place in the universe. How does the existence of these objects influence our perception of the cosmos? Magnetars are not only fascinating for their physical properties, but they also remind us of how little we truly know about the universe and how much is left to discover. So as we continue to explore the cosmos and unravel the mysteries of magnetars, it is essential to keep an open mind to new ideas and theories. Every answer we find can open the door to new questions, and in this journey of discovery, the potential is infinite. Magnetars, with their extraordinary nature, invite us to keep searching and to keep marveling. Have you ever thought about what could happen if a magnetar were to come within a dangerous distance of our planet? Imagine a cosmic object with a magnetic field so powerful that it could disrupt the technology we use every day. And this is not a science fiction story. Magnetars are extremely dense stars, and although they are light years away, their influence could extend far beyond their current location. To understand the impact a magnetar could have on Earth, it is first important to know its nature. A magnetar, being a neutron star, has a magnetic field that can be trillions of times stronger than that of our planet. This raises a troubling question. What would happen if a magnetar got close enough for its magnetic field to affect Earth? The truth is that, while the probability of this happening is extremely low, just imagining it opens the door to a series of fascinating and alarming consequences. Let's suppose a magnetar were located just 1,000 light-years away. In that case, its magnetic field could interfere with the technologies we use daily. Computers, mobile phones, and any electronic devices could be affected. Additionally, satellites in orbit could experience severe problems, potentially leading to disruptions in communications and navigation systems. Imagine a world where social media goes down, or where you can't use your GPS to get home. This scenario, while extreme, makes us reflect on the vulnerability of our technology in the face of the vastness of the universe. But the effects of a magnetar are not limited to technology. They could also influence the biology of Earth. Such magnetic fields can affect migratory birds which rely on Earth's magnetism for navigation. What would happen if the course of their migrations were altered? The consequences for ecosystems could be unpredictable. Studies have shown that magnetic fields can influence the behavior of many animals. So, if a magnetar were close enough, not only humans but also the animal kingdom could experience drastic changes. Moreover, the radiation emitted by a magnetar is a major concern. These cosmic objects are known for their powerful bursts of X-rays and gamma rays. If a magnetar got close enough, we could be exposed to radiation levels that would be harmful to life on Earth. This raises the question, are we protected from these bursts? Fortunately, the atmosphere and magnetic field of our planet act as a shield. But there are no guarantees if a magnetar were nearby. Gamma-ray burst events, which are often associated with magnetars, are another aspect we cannot ignore. These bursts are of extraordinary magnitude, and in theory, if an explosion were to occur near Earth, it could wreak havoc on our atmosphere, affecting the climate and potentially making life on the planet unsustainable. The very idea of a nearby gamma-ray explosion is terrifying. But it is a phenomenon that astrophysicists study to better understand its implications. While all these possibilities may seem alarming, they also remind us of how small we are in the vast universe. The distance that separates us from these cosmic phenomena provides a certain sense of calm, but we must not lose sight of the fact that the universe is full of surprises. Each new discovery about magnetars and other celestial objects helps us better understand our place in the cosmos. And what about life on Earth? Although magnetars are fascinating and sometimes unsettling, it is important to remember that their distance protects us. The reality is that the Milky Way is a vast and largely unexplored place. Catastrophic events may seem imminent, but the probability of a magnetar directly affecting our lives is minimal. However, science is always evolving, and each new research on magnetars provides us with valuable information. It helps us better prepare our technology and understand the limits of what we know. Researchers continue to explore magnetars, and each finding can change our perception of how we interact with the universe. As we delve deeper into the study of these objects, we also realize the importance of taking care of our own planet. Vulnerability to cosmic phenomena reminds us that we must protect our environment and prepare for any eventuality. Science not only offers us answers, but also the opportunity to act based on what we discover. In conclusion, while magnetars may seem distant and unrelated to our daily lives, their study offers us a unique perspective on the universe and our existence within it. The possibility of a magnetar affecting Earth is remote, but the lessons we learn from them are invaluable. They teach us to look to the sky, to question what we know, and to prepare for any surprises the universe may have in store for us. What happens when a magnetar wakes up? A spectacular event occurs known as a gamma-ray burst, and these phenomena are one of the most enigmatic and powerful manifestations of the universe. But what triggers these explosions, and what does it really mean for us? Let's delve into this fascinating topic. First, it is essential to understand what these gamma-ray bursts are. Imagine that the universe has a giant light switch, and every time a magnetar releases its energy, it's like turning on a lighthouse that shines brightly for a brief moment. These bursts can release more energy in a few seconds than our sun will emit in its entire lifetime. This leads us to the question, how is something so powerful possible? The answer lies in the extreme magnetic field of magnetars. When the stresses in their magnetic fields become too great, it's like a spring about to break. That accumulated energy is explosively released, generating gamma rays that travel through space at speeds close to the speed of light. But what does this mean for astronomers trying to understand these events? Astronomers use special telescopes to detect these explosions. Imagine they are listening to the echoes of a great explosion in the cosmos. Every time a magnetar releases its energy, the telescopes capture those echoes in the form of light and radiation. This allows them to study the nature of these explosions, which are often brief but intense. But do these events have any impact on our planet? That's an interesting question. The good news is that, although these explosions are incredibly powerful, most of them occur at such great distances that they pose no danger to Earth. However, if a magnetar were close to our solar system, the consequences could be devastating. The intense radiation could affect our atmosphere and even disrupt communication systems and satellites. This leads us to wonder, what would happen if one of these cosmic objects were closer than we think? Gamma-ray bursts also play a crucial role in understanding the evolution of the universe. Every time a magnetar explodes, we can gain clues about the formation of elements in space. It's as if the universe is sending coded messages that scientists are trying to decipher. By studying these explosions, astronomers can learn more about how stars and planets form. A related phenomenon that is often mentioned is gamma-ray bursts, which are very brief and powerful flashes of light that may also be related to magnetar events. Although magnetars are not the only source of these explosions, their study has provided invaluable information. So how are they exactly related? Gamma-ray bursts are usually more distant and may be associated with the death of massive stars. However, when a magnetar activates, it can generate bursts that are shorter but incredibly intense. This leads us to think about how magnetars and these explosions might be connected in the grand puzzle of the cosmos. Moreover, it is important to consider that gamma-ray bursts offer us a window into high-energy physics. When these explosions occur, they release information about the fundamental laws of the universe. Scientists can study how matter behaves under extreme conditions, which in turn can lead to new discoveries in fields like physics and astrophysics. What secrets still await us in these explosions? As we have seen, gamma-ray bursts are more than just simple flashes in the sky. They are dramatic events that help us understand not only magnetars but also the very fabric of the universe. Each discovery brings us one step closer to unraveling the cosmic mysteries that surround us. But what else can we learn from these astonishing phenomena? Research on magnetars and their gamma-ray bursts continues to evolve. Each new technological advancement allows us to observe beyond what we once thought possible, providing answers to questions that previously seemed unreachable. So the next time you look up at the sky, remember that there is much more happening in the universe than meets the eye. In conclusion, gamma-ray bursts associated with magnetars are a reminder that the cosmos is full of surprises and mysteries. These events are the footprints of the extreme processes occurring in the universe, and as we continue to investigate, we are likely to discover even more about the nature of reality. Human curiosity drives us to keep exploring, and on that journey, magnetars are fascinating companions. The fascination with magnetars does not stop. In fact, the future of research on these cosmic objects is as promising as it is intriguing. What new surprises await us? Modern astronomy is equipped with advanced technologies that allow us to look beyond what our past generations would have considered possible. Magnetars, as neutron stars with extreme magnetic fields, are the focus of studies that could revolutionize our understanding of the universe. One of the most intriguing questions that arises is, how can we continue to learn about these phenomena? The answer lies in the combination of state-of-the-art telescopes and new data analysis techniques. Imagine a telescope in space capable of capturing radiations that are not visible to the human eye. With these devices, astronomers have begun to map the sky in different wavelengths, detecting emissions from magnetars that would otherwise remain hidden. Moreover, computer simulations are playing a crucial role in the study of magnetars. These simulations allow scientists to recreate the extreme conditions found near a magnetar. With them, we can observe how materials behave under pressures and temperatures not found on Earth. This approach not only complements direct observations, but also provides a theoretical framework for better understanding these objects in the context of modern physics. Magnetars are also helping to answer broader questions about the evolution of stars. What will happen to neutron stars that do not become magnetars? As research progresses, unexpected connections between different types of stars and their behavior over time are being discovered. Magnetars could be the key to unraveling these mysteries, revealing secrets about the life and death of stars in our galaxy. We cannot forget the impact that the search for magnetars has on education and scientific outreach. Each new discovery about these stars generates renewed interest in astrophysics, inspiring new generations of scientists and enthusiasts to look to the sky. Is it not exciting to think that through the study of such distant phenomena, we can understand more about our own place in the universe? International collaboration is another fundamental aspect of magnetar research. Astronomers from around the world are working together, sharing data and resources. This not only accelerates the discovery process, but also creates a global community united by curiosity. The question of how and why certain phenomena occur in space becomes a collective effort, where everyone contributes their piece to the puzzle. As we move into the future, the possibility of discovering new magnetars keeps us intrigued. What if we find one closer to Earth? This could completely change our understanding of the effects these objects have on their environment. Research on magnetars could unveil valuable information about cosmic radiation and its influence on our planet, as well as on life itself. Theories about the formation of magnetars are also constantly evolving. Each new finding can challenge our previous assumptions. Could there be more types of magnetars than we currently know? As more and more examples are discovered, existing classifications may need adjustments. This dynamism in science is what makes it so exciting, and magnetars are a clear example of it. The search for answers to questions yet to be formulated is the driving force of science. Magnetars could be the gateways to new areas of research that we have yet to imagine. What other cosmic phenomena might be related to them? With each discovery, new lines of inquiry open up, promising to unearth even more secrets of the universe. it is fascinating to think about how magnetars may be connected to other aspects of the cosmos. Perhaps in the future we will discover that these objects play a vital role in the formation of galaxies or in the evolution of other celestial bodies. Human curiosity has always been the engine of exploration, and magnetars are a field of study that promises to keep that drive alive. Finally, the importance of magnetars lies not only in what we know, but also in what we still have to discover. Each new advance in their study could illuminate areas of physics that are currently dark. As we venture into the future, research on magnetars will be one of the many stories that continue to unfold in the vast theatre of the cosmos, challenging our understanding and expanding our horizon of knowledge. The exploration of the universe is an endless journey, and magnetars are just one of the many fascinating stops along the way. Who knows what other secrets they hold, waiting to be revealed by the curious minds that dare to ask. Science advances, and with it, our understanding of what lies beyond our planet. On the horizon of knowledge, magnetars shine like beacons of mystery, inviting us to keep exploring and discovering. Magnetars are truly fascinating, and in the realm of astrophysics there are curiosities that can leave anyone speechless. For example, did you know that the amount of energy a magnetar can release in just 1 second is equivalent to what our sun emits in millions of years? This immense energy is not just an impressive number, it is a reminder of how powerful these celestial objects are. Magnetars are often said to be like superheroes among neutron stars. They have magnetic fields so intense that they can distort the matter around them. Imagine that the gravity of a magnetar is so strong that if you were next to it, your body would be crushed as if you were being squeezed by a giant. Can you imagine a place where matter behaves in ways you would never have thought possible? There is something else that makes magnetars unique: their life cycle. Neutron stars are often thought to be long-lived, but a magnetar can burn out in just a couple of thousand years. Yes, just a couple of thousand years compared to the life of a normal star that can last billions. What if I told you that its life is like a spark in the darkness of the cosmos? In the world of astrophysics, magnetars also stand out for their ability to generate bursts of X-rays and gamma rays. These bursts are so bright that they can be detected millions of light years away. Imagine looking up at the sky and suddenly seeing a flash of light that could rival that of 1,000 suns. Isn't it amazing to think about what this means for observers on Earth? The communication between magnetars and other celestial bodies is an intriguing phenomenon. It is believed that the radiation emitted by a magnetar can alter the behavior of charged particles in its environment. In other words, a magnetar can influence the activity of electrons and protons around it, creating a cosmic ballet of energy and light. Can you imagine witnessing a spectacle that lasts millions of years? Moreover, there is the possibility that magnetars have companions. Some scientists suggest that they may form pairs with other neutron stars. What would happen if two magnetars met? Such an event could result in an unprecedented explosion of energy, a true cosmic spectacle that could illuminate the universe for a brief moment. Another interesting fact is that, despite their incredible power, magnetars are quite rare. In our own galaxy, it is estimated that there are only a few hundred of them. To put it in perspective, consider how many stars there are in the Milky Way. Over 100 billion. How is it possible that such powerful objects are so uncommon? It has been suggested that magnetars may have a significant impact on the formation of new stars and planetary systems. The energy released during their explosions can trigger the formation of clouds of gas and dust, which eventually condense into new stars. So in a way, magnetars are not just destroyers, they can also be creators. Isn't it fascinating to think that the life cycle of stars is connected in such an intricate way? The story of magnetars intertwines with that of other astrophysical phenomena. Some scientists believe they could be responsible for certain gamma-ray events we have observed. These explosions, often catalogued as the most powerful in the universe, may be caused by the release of energy from a magnetar at a critical moment. Who could imagine that such a distant object could influence such dramatic events? The fact that magnetars can influence life on Earth is another intriguing aspect. If one were to get close enough, its radiation could affect our atmosphere and potentially our technology. Have you ever wondered what it would be like to live under the shadow of a magnetar? Life might be very different. Research on magnetars continues. Each new discovery offers a deeper glimpse into the workings of the universe. How is it possible for such an intense magnetic field to be maintained? What mysteries do we still have to unveil? Science advances with each answer, opening new questions that seem even more exciting. Over the years, our understanding of magnetars has evolved. What once seemed like a simple phenomenon has revealed impressive complexity. Current research not only helps us understand these titans of the cosmos, but also gives us clues about the evolution of stars and the dynamics of the universe. What other secrets do magnetars hold for us? Finally, the magnetic field of a magnetar is not just a curious fact, it is also a reminder of the unknown that still surrounds us. Every day, scientists work hard to unravel the mysteries of the cosmos. And magnetars are undoubtedly one of the most intriguing pieces of the puzzle. Who knows what else we will discover about these fascinating objects in the future? Have you ever stopped to think about the magnitude of the universe and the extraordinary objects that inhabit it? In exploring the fascinating world of magnetars, we have discovered not only their uniqueness but also the impact they have on our understanding of the cosmos. These mysterious objects are like cosmic beacons, illuminating aspects of astrophysics that once seemed unattainable. But why is it so important to continue researching them? Magnetars are not just a curious phenomenon. They are the key to unveiling many secrets of the universe. By studying their formation and unique characteristics, scientists can shed light on the processes that shape stars and matter in general. Can you imagine how understanding just one type of star could revolutionize an entire field of study? What we learn from magnetars could change our perspective on physics as a whole. It is fascinating to think that in the vastness of space there are things so powerful that they can alter the very structure of space-time. Such phenomena invite us to reflect on our own existence and the place we occupy in the universe. Human curiosity drives us to ask, what else could we learn if we continue to investigate? Science never stops. And each answer generates new questions, creating a cycle of discovery. The search for answers about magnetars also helps us understand what surrounds us on Earth. For example, by studying their powerful magnetic fields and X-ray emissions, scientists can learn about the nature of radiation and how it affects our planet. Did you know that this knowledge is not just theoretical, it has practical applications in technology and medicine? So, every time we hear about a magnetar, we are not just talking about a distant object, but about something that can influence our daily lives. You might be surprised to know that despite their remoteness, magnetars teach us about life itself. They show us the fragility and resilience of the universe and remind us that although we are small compared to these cosmic giants, our curiosity and desire to understand are equally powerful. Isn't it amazing to think that through science we can connect our existence with the vast cosmos? Let us also reflect on the importance of scientific collaboration. Studies of magnetars involve astronomers, physicists, and other experts from around the world. Together, they are unraveling the mysteries of the universe. The diversity of thoughts and approaches is what drives progress. Can you imagine a world where we all work together toward a common goal? Science shows us that this is possible. Moreover, it is essential to remember that science knows no bounds. Magnetars represent only a small part of a vast and enigmatic universe. How many other extraordinary phenomena await discovery? The exploration of the unknown is a continuous adventure that keeps us all intrigued. Each new piece of evidence or discovery about magnetars reminds us that there is always more to learn. The story of magnetars is also a story of perseverance. Research in this field has been a journey filled with challenges, but each obstacle has led to an advancement in understanding. This teaches us a valuable lesson. The pursuit of knowledge requires time, dedication, and sometimes a bit of courage to keep going even when the path is uncertain. Who hasn't faced challenges in their own life? Just like scientists, we all encounter obstacles that we must overcome. As we conclude this journey through the fascinating world of magnetars, it is impossible not to feel inspired. These objects are not just a subject of study, but a constant reminder of the greatness of the universe and our capacity to understand it. Each new question that arises from our research is an invitation to continue exploring, discovering, and marveling. The importance of magnetars in modern astrophysics cannot be underestimated. As we advance in our knowledge, it is crucial to remember that we are on the brink of a vast ocean of information yet to be discovered. What secrets still remain hidden in the darkness of space? Each discovery about magnetars brings us one step closer to answering those questions. Finally, never underestimate the power of curiosity and the desire to learn. As we look to the future, research on magnetars will continue to play a fundamental role in our understanding of the universe. Science is an endless journey, and each of us has the ability to be a part of it, whether through research, education, or simply sharing the wonder we feel when looking at the stars. So as you gaze at the night sky, think about magnetars and all that we still have to learn. What other mysteries does the universe hold for us? The answer is out there, waiting to be discovered. The exploration continues, and the journey has only just begun.